Hello and welcome into the video for the content of Lesson 6 for Precalculus 1. In this video, we are going to be looking at complex numbers and then solving nonlinear equations. So first off, let me share the document camera. There'll be a lot of talking and not a lot of writing on your guys' end. So all right, so first, the definition. So what is a complex number? So a complex number is an expression of the form a plus bi. And so we have two parts of this. So we say that a is the real part. So all the numbers we've been dealing with up until this point. And b is the imaginary part. And that's what this I is indicating. That, hey guys, here's the imaginary part. And this I actually has a value. I is equal to the square root of -1. Hey, wait, I thought we couldn't have negative roots. We can't until today. Now we do. Now we have, because this complex number, we have the real part, we have an imaginary part. And this imaginary part is equal to square root of -1. And so if I square both sides, what happens? I get I squared on the left. And if I square the right side, the square takes out the square root. So we get what? That I squared is -1. And so this is super important. We're going to use this a lot when dealing with complex numbers. So for example, what does this look like? We might have something like 3 plus 4i. And so the real part is 3. The imaginary part is positive 4. So we don't include the I, it's just the number. If this was a minus, if this was 3 minus 4i, the imaginary part would be -4. So for our arithmetic, so let me do this. So to add or subtract complex numbers, we combine the real parts and we combine the imaginary parts separately, of course. To multiply complex numbers. So we have something like what? We might have like 1 plus I times 2 minus 3i. So these are two complex numbers being multiplied together. So we have what? Two binomials essentially. So to multiply complex numbers, we FOIL. We use FOIL. And then here now, so whoops. So to divide complex numbers, so now we're going to have a complex number in the denominator. We're going to have an I in the denominator, and we want to get rid of that I. So it's very similar to when we had a square root in the denominator, and we want to get rid of the square root. What do? We multiplied by the conjugate. So same thing here. So you can see how all this kind of ties together. Add the real parts, add the imaginary parts, FOIL for multiplication, and to divide, we multiply the numerator and denominator by the conjugate of the denominator. So just to kind of show you, I won't work it out because we will work out problems in the second video. Excuse me, but what if we have like 3 plus 5i over 1 minus 2i? Well, what we would do is multiply by the conjugate of the denominator. So 1 plus 2i, 1 plus 2i. Have to FOIL the numerators, FOIL the denominators. When I FOIL the denominators, the I piece will be gone. And then I can write this in a plus bi form. And so then lastly, the last thing I want to talk about with complex numbers is taking square roots of negative numbers. So we have that if r is positive, then the square root of minus r, well, if we use our radical rules, negative r is the same as minus 1 times r, which we can break this up into square root of negative 1 times square root of r, if you remember from our radical rules, day number or lesson number 2. And then square root of negative 1 is what? That's I. So we get I times the square root of r. If we have a square root, so say I have something like I times root 3, I write the I in front of the radical. But let's say this was like I times square root of 16. Well, obviously square root of 16 is 4, so I would write this one as 4i. And the reason I write the I in front is because if I tried to write it as like square root of 3i, it's like, wait, is it square root of 3 and the I is at the end, or is the I underneath? I'm not really sure. So this way, by putting the I in front, then we know that it's the imaginary unit I. All right, so that is our complex numbers. And again, we'll see some examples of doing all that stuff in the second video. So now we're going to look at solving nonlinear equations. So we looked at nonlinear inequalities in the last lesson. But now we have nonlinear equations, and we're essentially going to have the following types. We're going to have quadratics. So remember, by nonlinear, that means what? It means it's not x to the first power. If it's x to the first power, that's a linear equation, and we know how to solve those now. But quadratic is x squared, so that's not a linear equation. We can have rational equations. So we have equations with a bunch of fractions in them. And the fractions could have, they could be rational expressions, right? So polynomial in the numerator and or denominator. We have radical equations. So an equation that has a square root. And then lastly, absolute value equations. So these 4 different types are what we're going to look at. So first, let's look at our quadratic equations. So a quadratic equation has the form ax squared plus bx plus c is 0, where a is not equal to 0. Because if a is 0, there is no x squared, and therefore now it's a linear equation. So we kind of have to put that in there. So we have a few different ways we can go about this. First, we have zero property rule. And the zero property rule says that if a times b is equal to 0, then a equals 0, b equals 0, or both equal 0. And so if I can factor this quadratic equation, so let's look at an example here quick. Let's say I have x squared plus 5x minus 24 is 0. Well, I can factor this guy into x plus 8, x minus 3 equals 0. So now by zero property rule, if this times that is 0, then either this is 0 or that is 0 or both. So that means x plus 8 is 0 or x minus 3 is 0 is going to make this whole thing 0. So x is minus 8, x is positive 3. So that's if we can factor it, set it equal to 0, and then use zero property rule. Now, I'm going to write this in red. So the official mathematical name of this is a simple quadratic. I hate this name because it's not simple, and more often than not, and I would rather call it's a looks simple, but most people are going to get it wrong. And the reason is as follows. So what a simple quadratic is something that looks like this. X squared equals c. So it's like, okay, how do I get x by itself? Well, I would take the square root of both sides. So, okay, the answer must be x equals square root of c. And that's why I call it the looks simple, but everybody's going to get it wrong. Because it's not x equals square root of c, it's x equals plus or minus square root of c. So for example, if I have x squared is equal to 9, if I take square root of both sides and don't do plus or minus and just say, oh, okay, x is 3. Well, that's true, because if I plug 3 in here, 3 squared is 9. But what else squared equals 9? Well, negative 3 squared. So negative 3 times negative 3 is also positive 9. So that's why we have to please, please, please remember the plus or minus. Next. So we have this technique known as completing the square. Honestly, I probably would not use this method to solve a quadratic. You can, but it's a lot of work and a lot of steps that you could screw up a number and then you're in big trouble. But we will have to know how to complete a square later on when we start talking about circles and radius, things like that. So it in a standard form of quadratics. So you do have to know how to complete the square. It's just I probably wouldn't use it to solve quadratics. So the steps for completing the square. We're going to first move the variables to one side and constants to the other. So you can end up with something that looks like ax squared plus bx equals some number c. And the key here, if we're going to complete the square, is a must be 1. A must equal 1. So if there was like a 2 here, if this said 2x squared, I'd have to divide everything by 2 to get x by itself. And once I have x by itself, I take 1/2 of b. So if b is 8, half of that is 4. If b is 10, half of that is 5. Once I have that number, I square it. So if b is 8, half of it is 4, square it, 16. And now that I have 16, I'm going to add to both sides. So add 16 on the left, add 16 on the right. And once you do this, you can now factor the left side with the variables. And just as a note, the factor will have whatever 1/2 of b was. So if, let's say this is minus 8x, half of b is minus 4. So when I factor this, it's going to have minus 4 in the factor. And now that I have that, now I have a quote unquote simple quadratic. So then I can solve it. I can take the square root of both sides, plus or minus, and solve it that way. So we can factor it. If it doesn't factor, we could complete the square, or the other thing we can do, and we can always use this, is the quadratic formula. So you probably know this, or you think you know it, but be careful because I see it a lot of times on tests. People try to solve quadratics using the quadratic formula, but they have the formula wrong. So if the formula is wrong, you might as well not even use it because you have no chance of getting it right. So the quadratic formula says that the following. So if ax squared plus bx plus c is 0, where again a is not 0 because we need a quadratic, then our values of x are equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And I know there's little songs that people sing and do all that kind of stuff. However you need to remember it, that's fine, but that's, oh, the other thing too, so if you are in my class and you're taking the test, I give you guys a cheat sheet or like a note sheet. I would probably put this on there and make sure you have it written down correctly. And so that's it. You'll plug the value of b in here, the value of b, the value of a, the value of c, the value of a. And once you do that, simplify this whole thing. And even if it's something you could have factored, you're still going to get the same answer using the quadratic formula. And so one thing about the quadratic formula, this guy here, this value under the radicand, so the number that's underneath the root symbol, has a name, and it's called the discriminant. Not the discriminant, just discriminant. And so if I calculate this, if I plug in b squared, well, b and square it, and then subtract 4ac, I'm going to get a couple different options. First of all, so let's call this like capital D for discriminant. So if the discriminant is greater than 0, then this equation has two real solutions. If the discriminant is equal to 0. So if it's equal to 0, it means what? This whole piece is gone. So you just have negative b over 2a, which is what? Just one real solution. And third, if the discriminant is less than 0, so I'm going to have what? A negative number under the root. And when I have a negative number under the root, that means what? Complex number. So this has two complex solutions. So that's how we can use the discriminant. There's some problems in the homework. There's some problems in the in-class assignments that you're going to have that say, okay, um, you know, determine what the value of the discriminant is, and then based on that, how many types of solutions are there. So that was our quadratic equations. We also have rational equations. And so, for example, I could have something like 3 over x plus 5 over x plus 2 is equal to 2. So that is a rational equation. I have an equation that has rational expressions in it. And so to solve these, I multiply every term by the least common denominator. So just like we did back with our rational expressions, when we had compound fractions, we could find the least common denominator, multiply everything by the LCD, and it got rid of those extra fractions. Same thing here. So my LCD is what? X times x plus 2. So I multiply this times x plus 2, multiply this one by x times x plus 2, multiply this one by x times x plus 2, and then solve it from there. And that's it for rational equations. And again, we'll look at some of those in video 2 if you need examples of it. But at least for now, the content, it's like, oh, you have a rational equation. What do? Multiply everything by the LCD. Radical equations. So I could have something like, let's say 2x minus 1 is equal to the square root of 2 minus x. So I have an equation that has a square root in it. So with these, to solve these, I need to first get the square root by itself, if it isn't, or the radical, let's say. Get the radical by itself. So I guess technically you could have cube root equations, fourth root equations, etc. So let's just work with this one like a square root. So get the radical by itself, and then to get rid of the square root, we have to do what? We have to square it. So we are going to square both sides. And now be careful, because let's say this example here, if I square this side, I just get 2 minus x. But if I square this side, I have what? I have a binomial squared. And by my binomial theorem, it means what? I need 3 terms. And so I have to do 2x minus 1 times 2x minus 1, FOIL it out, get some value here, and then solve it. So that's how we solve radical equations. Primarily the square root ones is what you guys will have to deal with. So you'll get the radical by itself and then square both sides. Now we're going to switch to my big red pen here. So with rational and radical equations, we must check our answers. So with linear equations, if you don't check your answers, okay, that's up to you. With quadratic equations, if you don't check your answers, okay, that's up to you. But with rational equations or radical equations, we must check our answers. And the reason is that, let's say I solve this one and I get x equals -2. Well, that's not possible, right? I can't have x equals -2 because that would make this denominator 0, which is a big no-no. So you can't have a 0 in the denominator, so we have to check our answers to make sure that we didn't create that situation. And similarly, with the radical equations, because I squared both sides, I might have created an equation that's not really true. So say, for example, is this true or false? -1 equals +1. Well, obviously that's false. But what if I square both sides? Like I do when I solve a radical equation. -1 squared is +1. +1 squared is +1. That's true. So now I just created a true equation by squaring both sides, even though I didn't start with a true equation. So we have to check our answers on those type of equations. And then lastly is our absolute value equations. And so if you remember our absolute value inequalities, we did what? We set what was inside greater than our C or less than or equal to our -C. So we're still kind of going to follow the same thing. So if I have some absolute value is equal to a value C to solve this, I say x equals C and x equals -C. And then solve those two equations, and the values I get for x are my answers for that absolute value equation. So that was a little longer video than normal, about 19 minutes, I think, almost 20 minutes. So apologize for the lengthy content. Probably should have given you a heads up at the start, maybe, watch half and then watch the second half or something. But that's our content for lesson number 6. So come on back. We'll do a bunch of problems with all these types of content we just talked about. You'll be ready for the homework.